Hello, am I audible?
Yes, ma'am.
Okay. Can you see my screen?
Yes, ma'am.
Okay, sir. Thank you. All right. I think I'll just begin in 1 2 seconds. Just a All right. So welcome back to week 2 of the problem solving sessions. I am Shreya, one of the TAs of the course, and today we'll be discussing few problems, and I'll try to show you how to solve questions which are related to probability distributions, random variables, cumulative distribution functions, probability mass functions, probability density functions, and all of the concepts that were discussed during week 2 lectures. So before proceeding, I have two questions. Is there anybody who has not been through uh, week 2 lectures, or rather how many of you have been through week 2 lectures before joining this session? Can you please raise your hand if you want to? So I'm assuming all of you have attended, right? Anybody? Anybody would like to speak up? All right, and
Yes,
also
ma'am.
you have attended. Okay. And is there anybody who has attended yesterday's session?
Yes, ma'am.
Okay, fine. All right. So I'll just walk you through my slides. So what was discussed mainly were concepts related to random variable, cumulative distribution functions. What do we mean by a distribution function? What are the types of random variable? What do we mean by a probability mass function? What do you mean by a probability density functions? And how can we define distribution of functions of random variables? So these were the key concepts which were discussed in the lectures. So I'll just brush up whatever was discussed. So this, if you have not been through the lectures, kindly go through it and then you'll understand better. So if x is a random variable, so last week we learned what we mean by a probability space. So this is my sample space, this is the sigma field, and this is the probability measure. So let's say here I have, let's say this is my omega, which is the sample space, and let's say this is my script f, which can be, one of the possibilities can be power sets of omega. And here we have a few outcomes of omega which is happening. So what x will do, x will take events defined on this omega, and it is going to x omega, it is going to map these to a real valued function, where this is the real line. So any such variable which maps outcomes into the real line such that this one, if x inverse this thing, it belongs to script f. So for any point in on the real line, if we can get its pre-image, it should belong to script f. Then we call that to be a random variable. So this was discussed. Then we also learned about what do we mean by a distribution function. So these are very important 4 properties which we'll need to solve the problem. So what are the 4 properties? The first one is that it should lie between 0 and 1. And the second one is it should be monotonically increasing, where whenever x1 is less than x2, fx1 should be less than or equal to, this we have to be very careful, it has to be less than or equal to fx2. The third property was that f limit of this real valued function as x approaches minus infinity should be 0. So let's say this is a very small number, minus infinity. Okay, so as x moves along near closer and closer to minus infinity, in a limiting sense fx will also move towards 0. And this one should also hold. As x tends to plus infinity, as x moves here, fx should also go to 1. And the fourth property was that f should be a right continuous function, which means that limit x tends to, let's say, y plus fx should be equal to f of y. So what it means that, let's say if I have a function here, so this is my y, let's say this is fy. So if x moves from here towards y from the positive side, then the fx value in a limiting sense should go to fy. Fx should also approach fy. This is what we mean by right continuity. Whenever we are approaching from the right side, let's say x is a little bigger than y, let's say y plus epsilon, where epsilon, whenever epsilon is tending to 0, fx should also go to fy. Okay, so this was discussed. The other thing that was discussed was what do we mean by a cumulative distribution functions. So by definition, this we have to remember. So fx is probability x less than equal to x, where this thing can be written in a more detailed way. It will be the probability associated to all outcomes in sigma such that the map of these omegas are less than equal to x, where x belongs to the real line. Okay, so this is a very detailed description of whatever is going on. To write it simply, put it simply, we are going to use this notation from this class onwards. Okay, and also we learnt about, okay, can you see my cursor? And also we learnt about types of random variable. So there were 3 types. Anybody remembers what were the 3 types?
Discrete, continuous, mixed.
Yes, discrete, continuous and mixed. So in discrete, what do we have? CDF has countable, this is an important word, countable number of discontinuities. Okay, so then the discontinuity points were described as x1, x2, x3, where probability at each x equal to xi, at each x equal to at each discontinuity point, there will be some probability associated with it. And this one would be, fx would be summation of probability x equal to xi for all xi which is less than equal to x. So those were called the jump points. So if we consider a CDF of a discrete random variable, it was something like a step function. Okay, starting from 0 and then moving on to 1. And these would be the breakpoints. Okay, these would be the breakpoints. Also, one thing we learned, probability mass function. The thing we should keep in mind is whenever we are talking of probability mass function or PMF, then we are talking about a discrete random variable. Okay, then Px is defined as probability x equal to xi, and it has the following properties. It should be greater than equal to 0, it should always be non-negative probability mass function, and it should add up to 1 for all x in the range. Okay, so this is this was the definition of probability mass function. We'll do sums so it will become clearer. And also we learnt about continuous random variable. So continuous random variable, the CDF of a continuous random variable is written in this manner. Okay, this will be the definition of the CDF of a continuous random variable, and this one ft dt inside the integral, this would be the probability density function. So ft is my PDF. So whenever I'm talking about PMF, I'm talking about some discrete random variable, and whenever I'm talking about some probability density function, then we are talking about some continuous function. And these properties also we should remember. So these are analogous to the discrete cases as well. There also we saw that the probability mass functions should be non-negative and they should add up to 1. So here also the density function should also be non-negative, and here instead of summation, because it is a density function, it's a continuous function, that's why we are, instead of summation, we are going to take integral over minus infinity to infinity. This should be equal to 1. And how can we get this ft dt, the probability density function? Another important thing is that this can be obtained by, so PDF can be obtained by doing a difference PDF of x, fx, PDF will denote as small x, and CDF we are going to denote by capital X. So if we differentiate the CDF of a continuous random variable, then we are going to get the probability density function. And the third type that was discussed was mixed. So in case of mixed, as we can see, it will be a discrete plus discrete plus continuous. So it will be a mixed one random variable where the CDFs would be mixed, and we would have, so then the summation and the integral together, if we add them up, then it will come to 1. Individually, these components are also greater than equal to 0. So the left hand side is by default greater than equal to 0. And also we have these two components, the discrete component and the continuous component, should add up to 1. Okay. And also how to calculate this notation we have used. If A probability x lies between A to B, where B is included would be FB minus FA. So we would write probability X less than equal to X as Fx. So wherever we have this equal to sign, we are going to put it exactly, and wherever we don't, then we can put some other notations. Okay, like for example this one, probability A less than equal to X less than equal to B, it means that X lies between A and B. So how can we get that? Till B we have this much, and including A we have this much. So this section would be total minus infinity to infinity B, I mean this entire region minus infinity to minus probability minus infinity less than equal to A, because this is open interval A. So that A point probability will also go out. Okay, but if we put an less than equal to sign over here, it means that the A point is included. That is why till here the A point was excluded. So we have to add probability A X equal to A over here. Okay. Similarly, if B is excluded, then we have to exclude, because B was included here, so we have to exclude probability X equal to B from this thing. Okay, these will hold not mostly for discrete random variables. For continuous random variable, probability at a certain point will always be 0. So it doesn't matter for a continuous variable. We don't need to do these kind of adjustments. Okay, so this is something we should always keep in mind while solving sums, so that we are not making any mistakes. Okay, and then we also learned about function of some random variable, where if we know the distribution of X, we can find out the distribution of Y given that G satisfies some properties, which is G is Borel measurable, and every continuous or piecewise continuous functions, if G is measurable, then we can also find out distribution of Y. And here we will be using continuous or piecewise continuous functions, which are Borel measurable function, and thus this thing Y will also be a random variable in that case. So whatever sums we are going to do will be based on the G's will be such that this will be a Borel measurable function. And also this was how we would find out the density of a transformed variable. Okay, so this it will be something like this, where Y equal to Gx, then this will be fx of G inverse Y into some normalizing constant, or the we have to adjust with Jacobian. So we are going to discuss it in subsequent classes. Okay, this was the gist of what was discussed during week 2 lectures. Anybody, if you have any doubt, and during the weekly lectures, few sums were also solved. So kindly go through them and let me know, or post it in the discussion if you have any doubts anywhere. But so far, is it clear? Can I proceed to the problems? Please answer. You can also type in chat box. That is also fine.
Yeah, ma'am, you can proceed.
Okay. Thank you. Fine. So I'll now proceed to the sums. So before proceeding, for every sum, I'm going to give you 2-3 minutes of time, so as for you to come up with the solution, and then I'm going to discuss. Okay. All right. So the problem is, let us consider a random experiment of choosing a point on the annular disk of inner radius r1, outer radius r2. Let x be the distance of chosen point from the center of the annular disk. So if this is the setup, then what will be the PDF of f x? Any idea how to proceed? So what they have asked is that, let's say we have an annular disk. So let us consider so to be so annular disk, we can consider it to be something like a spherical disk. Okay. So let's say we have two spheres here. This is one sphere, or better I use these. Okay, this is one sphere, and we have another one, something like this. Okay, something of this sort. This is my disk region. Okay, and this, let's say this is the center, and this entire thing is my disk. So what they have given is that this distance is r1 and this distance is r2. Okay. Now if we have so now we have to choose the random experiment is to choose a point on the annular disk of radius r1. So any point here can be chosen. It could be this point, it could be this point. Okay, so then wherever we choose, whichever point is there on the disk, my x should always be less than equal to R2 and should always be greater than equal to R1. Then if this holds, then only, this probability is always equal to 1. I think this you can appreciate, because the experiment is only considering points on the disk. Okay, so now the density function or PDF, so if I have to say density, the thing that comes to my mind is area. Okay, now I have to formulate the PDF in such a way such that the two criteria are satisfied. X in that range minus infinity to infinity, fx should be 1. So these are the two criteria that I must satisfy. Okay, so the thing is that I want to keep in mind is that this area, so if I have 2x always lies between R1 and R2. So R1 to R2, fx dx should be equal to 1. Okay, because this is the support of x. Now I am also thinking in terms of area. So let's say if I draw my fx like, so this total area, whatever we are doing, this is pi R2 square minus R1 square, total area of the disk. Okay, so now if I choose any point here, and with that radius if I construct a smaller disk, then that entire area will be something like this, pi x square. So keeping these things in mind, if I devise the fx in this manner, 2x by pi R2 square minus R1 square. So I am proposing something like this. Now we'll see, pi will not be here, sorry, because in the back of my mind I want something like this, pi x square by something like this. Okay, now if I propose this as my density function, let me see if I get the frequency distributions or not, the properties or not. So my fx is 2x by R2 square minus R1 square when x lies between R1 and R2 and 0 otherwise. So this thing will always be greater than 0, because R2 square minus R1 square equal to R1 plus R2 into R2 minus R1. So since R2 is always greater than R1, because this is the outer one and this is the inner one, so this will always be greater than equal to 0. And both R1 is also greater than 0, so fx will always be greater than equal to 0. This is satisfied. Now the second one is over the support of x, r1 to r2, fx dx equal to how much? So then r1 to r2, 2x by r2 square by r1 square will be, this is common, r2 square minus r1 square, integration r1 to r2, 2x. So this will be x square from r1 to r2 by r2 square minus r1 square. So this will come up to 1. So both the conditions are satisfied. Now, is it clear till here? Any doubt?
Ma'am, how could you write f of x equal to 2x by r2 square minus r1 square?
So I thought that if this is the entire area of the disk, so if I have to integrate over these two ranges, then it should be some, like, I did some sort of back calculation, okay? So if I put 2x over here, then only I'm going to get pi of r2 square minus r1 square, and that, I mean, then that will become 1. Okay? So the thing is to think in terms of area, the total area of the disk. So x should lie between r1 and r2, and this is my total area. So I have to divide my whatever is there metric by this thing. So whenever I integrate from r1 to r2, divided by this thing will give me my total area. That will be 1. So thinking along those lines, I came up with this distribution function.
Okay, thank you, ma'am.
Okay. So now if from here, if it is asked that, let's say r1 is 5, r2 is 10, then find the probability 7 less than x less than equal to 8. So then how I am going to do? Because my fx is this, 2x by r2 square minus r1 square. Okay, so here I am going to put 7 to 8, 2x by r2 square minus r1 square dx. So here it will be x square 7 to 8 by r2 square minus r1 square. So 8 square minus 7 square by 10 square minus 5 square. It will be 64 minus 49 by 100 minus 25, 70, sorry. This will be 15 by 75, that is 1 by 5. Okay. So the key thing here is whatever you've been given, think in terms of area, because we are finding out density. Okay. Density means divide by area. That's how. Is it clear? Any doubt?
Yes, ma'am, clear.
Okay. So now I'll move on to the next one. So here, anyone who attended yesterday's session, was this question covered? The previous one?
Yes, ma'am.
This one was covered?
No, ma'am. Second question is covered, ma'am.
Okay, so this one was not covered. Okay, fine. Okay, so here let x be a random variable with the CDF this. We have to find out probability x equal to 0 given probability x less than equal to 0.5. So probability x equal to 0 given x less than equal to 5 can be written as probability x equal to 0 intersection x less than equal to 5 by probability x less than equal to 5. Now x equal to 0 and also x less than equal to 5 will be probability x equal to 0 by probability x less than equal to 5. So now we have to find out these two probabilities separately and then get to the final answer. Okay, so now probability x equal to 0. Probability x equal to 0 means f of 0 minus f of 0 minus, which means what? That minus infinity to 0 we are taking from that entire range just before what is there 0 we are going to remove it. Okay, so f of 0 is what we'll put over here. So here x, when x equal to 0, fx is half plus 0 by 2, that is half. And when f is 0 minus, then that means x is slightly less than 0, then f value is 0. So probability x equal to 0 will be half. This much is clear? Alright. Now the second part is probability. So this part we have the value of the numerator. Now probability x less than equal to 5 means probability x less than 1 plus probability 1 less than equal to x less than equal to 5. Okay. So now probability x less than 1 is, if we put when x equal to 1, sorry, when x is less than 1, we have half plus 1 by 2. So this part, this is, sorry, what am I doing? Probability x less than equal to half one second, x less than equal to half, so this means, okay, sorry, this is 0.5, my mistake. 0.5. All right. So the numerator value, I'm really sorry for this typing and mistake. Now probability x less than equal to 0.5 would be here. X falls between 0 to 1. So f of 0.5 will be half plus 0.5 by 2. That is half plus 1 by 4. That is 3 by 4. Okay. Then the required probability will be half by 3 by 4 which will be 2 by 3. Is it okay? All right. This one. Here we have a random variable with PDF given by this thing. So we have to find probability x greater than equal to half. So here we don't know what the value of C is, but we have a PDF. So PDF, these two properties should hold for any PDF. So using these two, the first step is to find out the value of C, and then using C we can get the required probability. So how we'll do this? So if we break this thing up, mod x less than equal to 1, it means that the density function is something like this: cx square when minus 1 less than equal to x less than equal to 1 and 0 otherwise. So this is my PDF written in a simplified form. Okay. So now if we have to find out the value of C. So everywhere else we have PDF to be 0. So integrating over 0 will be 0. Only here we have something. So minus 1 to 1, cx square dx should be equal to 1. Because over the entire range of minus infinity to infinity, instead of minus 1 to 1, everywhere else fx is 0. So that will not have any contribution. So if we do this, then this implies C x cube by 3 minus 1 to 1. So C 1/3 minus of minus 1/3 equals to 1. So this implies 2c by 3 equal to 1, which implies c equal to 3 by 2. Okay. So the first step is now done. C equals to 3 by 2. So we have C equal to 3 by 2. Our fx is 3 by 2 x square when minus x less than equal to x less than 1, 0 otherwise. Okay. Now the question is to find out probability x greater than equal to half. So then it will be, because this is a continuous random variable, this is PDF. So continuous. So this will be half to 1, 3 by 2 x square dx. It will be 3 by 2 x cubed by 3 half 1. This will be half minus 2 to the power 4. So this will give you half minus 1 by 16. 16. This will be 7 by 16. Okay. Any doubt here?
Excuse me, ma'am.
Yes.
Ma'am, how you get the range -1 to 1, ma'am?
Because it is given x is less than equal to mod x is less than equal to 1.
Okay.
So this means -1 less than equal to x less than equal to 1. Modulo means it will convert to an absolute value.
Okay.
Okay. This one means modulo. So mod x equal to x when x is greater than 0 and mod x equal to minus x when x less than 0.
Okay, thank you,
Okay.
ma'am.
So when
Ma'am, one
x,
more doubt.
yeah. So when I'll
Uh,
just you understood, right? I don't need to explain. Okay.
ma'am, one more doubt, ma'am.
Hmm.
The range -1 to 1 cx square dx,
Hmm.
it became cx cube by 3.
This
How
is
it came?
integral, na?
Oh,
Integration we are doing here.
Okay.
So x square integration will become what? X to the power 3 by 3.
Okay, ma'am.
And then this is, since this is a proper integral, we are just putting limits. -1 to 1. So that will be 1 and -1. Just plain and simple integration.
Okay. Thank you, ma'am.
Okay, thank you. This one you understood, right? Modulo, what it means.
Yes, ma'am.
Okay.
Understood.
So because the mod function is defined in this way, mod x equal to, I'll write it again here a little bit clear for everyone else also. So mod x means x when x greater than 0 and minus x when x less than 0. So if we have x as -1, then minus of -1 will become, so let's say if x equal to -1, then mod x will be minus of -1, that is 1. Whenever x is negative. So if you have anything like mod x less than equal to 1, it means that x should fall between minus of this figure to this figure plus. Okay. All right. So now we'll move on to the next question. How do you think you should solve for this one? All right. So here we have a random variable with a CDF like this. Okay. Now we have to find out which of these are correct. So probability y greater than equal to 1/4. It means 1 minus probability y less than 1/4. Do you agree with me? Now this one will mean 1 minus f of 1/4. Sorry, 1 second. Let x, let y be a random variable with CDF. Which of these are correct? Okay. So this one will be 1 minus f of 1/4 is 1 by 16, that is 15 by 16. Okay, then here they are saying what is probability. Y greater than equal to half. This is 1 minus f half. So that is then 1. One minus 1, that is 0. So this is not true. So third one is this one. Okay, am I making some mistake over here? Alright, I think I'm making some mistake over here. I'll just go back to the basics and then write it out. So here fy equal to 1 when y is greater than equal to half. So means probability y less than equal to y equal to 1 when y greater than equal to half. It equals y square when 0 less than equal to y less than half and 0 otherwise. So probability y less than equal to 1/4 will be 1/4 whole square. It is 1 by 16. So here this thing is given wrong. This is an incorrect question. So it will be probability y greater than 1/4. So probability y greater than 1/4 will be 1 minus probability y less than equal to 1/4. So it will be 1 by 1 by 16, that is 15 by 16. Okay, so then this is correct. Alright, and then the second one we also checked, y greater than equal to half. It means 1 minus probability y less than half. It will be 1 minus f half minus. It will be 1 minus, when y is a little less than half, then f half minus is 1 by 4. So it will be 3 by 4. So this is wrong. Alright. Now the third one is probability. What we have to find out? 1/4 less than equal to y less than 3/4. 1/4 less than equal to y less than 3/4. So this means f of 3/4 minus f of 1/4. So f 3/4 means 3/4 is greater than half. So this thing we can write as, so to make it a little simpler, we can write this as probability 1/4 less than equal to y less than half minus probability half less than equal to y less than 3/4. Okay, so this means f half minus f 1/4 minus probability 3/4 minus plus probability y less than half. Sorry. So this one we'll write like this, and so 1/4 to half, and then half to 3/4. So this we can write as f of half minus f of 1/4 minus f of 3/4 minus okay. So here f of half is how much? When 1 is half is 1 minus f of 1/4 minus is how much? 1/16. Three-fourth minus is how much? It is also 1. Plus f of half is also 1. So 1 will cancel. We'll have 1 minus 1/16. That is 15/16. No, but this is 3/8. Some mistake I am doing. So extremely sorry for this. I think I wrote the numbers incorrectly. Yeah, 3/8. Really sorry for this. So this was 3/8. So then I don't need to worry. 3/8 is already less than half. 4/8 will be equal to half, but 3/8 is already less than half. So this thing will be f of 3/8 minus f of 1/4 minus. So 3/8, if we substitute, then what we are going to get? 3/8 whole square minus 1/4 whole square. So we'll have 9/64 minus 1/16. So we'll get 5/64. So then this answer is correct. Okay. All right. And then the next step is probability y equal to 1 by 4 is 1 by 16. So here probability y equal to 1/4 is probability y less than equal to 1/4 minus probability y less than 1/4. So here 1/4 is 1, when we are doing it, since it lies in this range, it's y square. So it will be 1 by 4 square minus 1 by 4 square. So it will be 0. Now since at any given point it is probability is 0, most probably this is a continuous type of a distribution. Okay. Or I think this is a continuous type of distribution because left continuity is also holding. F of 0 plus is also equal to 0. F of half plus, no, sorry. So this is a, no. All right. So then this option 1 and option 3 are the correct answers. Okay. Sorry for the confusion here in the entire thing, but I hope you got how to solve the questions. All right, I'll move on to the next one. So let an urn contain n cards with numbers from 1 to n. A card is drawn at random from the urn. Then what is the probability that the number on the card is divisible by 3 and by 5? So we have one card is drawn from the n set. Okay, so this one, what it means is that denotes the greatest integer function. So let's take an example. Let's say we have 10 cards. So number of cards by 3 will be 10 modulo 3, if you, or yeah, if we can, this thing we can write it like this. So it will be 3.33 something, greatest integer function, greatest integer which is less than equal to this number, then that is 3. So we have 3 cards, 1, 3 and 9. Okay, number of cards by 5, we have how many? 2, that is 5 and 10. How we are getting 10 by 5 greatest integer fraction? Okay, now 3 and 5 they are saying. I think there's some problem in the question. This should be OR. Alright, let's say we have something like 52 cards. Then how many divided by 5? 10. How many divided by 3? 52 by 3 modulo. How many will we get? 17. I think this problem. This should be OR. Okay. So what is the probability that a number on the card is divisible by 3 or 5? Is that this number n mod by 3 greater box function will give you all divisible by 3. N by 5 this thing will give you all divisible by 5. So if we go by this formula, probability A union B, probability A plus probability B minus probability of A intersection B. So if we tally these two, then there will be some cards which are also divisible by 15. So that will be double counted. That has to be removed from our entire set. So something which is divisible by 5 and something which is also divisible by 3, since these two are prime numbers, that number should also be divisible by 15. So if I have to find out the probability that the number on the card is divisible by 3 or 5, then this will be my probability. These many n by 3 box function number of cards divisible by 3 plus n by 5 box cards divisible by 5. We'll add that up and there will be repeated counting. So we'll just remove n divided by 15 box. Is it okay?
Yes, ma'am.
All right. This one. Okay. A shipment of 7 television sets contains 2 defective sets. A hotel makes a random purchase of 3 of the sets. If X is the number of defective sets purchased by the hotel, find the probability distribution of X. So all we have to find out is what is the probability X equal to. So the hotel makes in total 3 purchases. So X will be number of defectives. So X can take value 1, 0, 1, 2, 3. Okay. So probability X equal to 3 will be 0. Why? 3 defectives, it's not possible because there are only 2 defective sets. So now we have to find out probability X equal to 0, which means out of the 3 purchases that I've made, none of them are defective. So how can we choose 3 from a set of 7? We can choose it by 7 C3 ways. out of which none are defective. So if we had 7 total, we were 5 good and 2 defective. So if I have to make 0 purchases, then I have to choose all 3 from my good set. So then this will be 5C3 by 7C3. Okay. Similarly, probability x equal to 1 means total out of 7 I am choosing 3. That's my all possible situation. 1 I am choosing defective. So that one should come from the 2 defective sets. And the other 2 should come from the good sets. Okay. Similarly, probability x equal to 2 will be, I am taking both defectives and one I have to take from the not so defective thing. So solving these, what do you get the value as? So this will be probability x equal to 2. This will be probability x equal to 1. And this will be probability x equal to 0. Now, if you don't know the meaning of this thing, 5C3 means 5 factorial by 3 factorial into 5 minus 3 factorial. Okay. And 5 factorial means 5 into 4 into 3 into 2 into 1. 3 factorial means 3 into 2 into 1. 3 minus 2, 2 factorial means 2 into 1. So if I just 2, 2, 4, 3, 3, then this will be 10. 5C3 means 10. Okay. So using these formulas, just try to find out what these probabilities are and which one should be the correct option. The logic is understandable. Why we are getting these in these?
Yes, ma'am.
Okay. This one I'm sure you'll be able to calculate, but just if you can confirm one of the calculations for anybody who is very new and doesn't know how to calculate factorials and combinations, then you can go ahead and check it. So these will tally up to and give our distribution function, this one. This one is the correct answer. For x equal to 0, it will be 10 by 7C3. So 1 I'm going to do just for the sake of doing it. So 5C3 by 7C3 is 5 factorial by 3 factorial into 2 factorial divided by 7 factorial by 3 factorial into 4 factorial. This means 5 into, so this means 5 factorial by 2 factorial into 7 factorial. So here we have 1 by 2 into 7 into 6. Sorry, 1 second.
Ma'am, there is a
Sorry,
fourth.
here I missed 1 4 factorial. So 4 into 3 into 2 factorial, 2 will get cancelled. This will be 2, so 2 by 7. This will come out to be that thing, if you can check. This will be equal to 0.2857. Okay, here. So that's how. Fine, I'll just move on to the next problem. So which of the following are valid CDFs? Now what were the 4 properties of CDF? Should be this should hold, F should be right continuous, Fx should be greater than equal to 0 and less than equal to 1. Okay, and anything else I missed? There were 4 properties. What were they? Monotonically increasing. Yes, it has to be so let us consider this one. So here, if this is monotonically increasing, as the value of C is increasing, the function is also increasing. Okay, so property 4 is satisfied. It is lying between 0 to 1, that is also satisfied. When C is greater than 3, it is whatever value be it, plus infinity it's 1, minus infinity it's 0. So those 3 are satisfied. What we have to check? Whether it is right continuous or not. So f of 0 plus, if we put 0 here in the value of C, then that is 0, which is equal to f0, because at 0 also the value is 0. Okay, what about the next point? If we have f1 plus, if we substitute the value of x as 1 here, then we have 0.25 plus 0.25, and f1 will be, if we substitute here, this will be 0.5. Okay, so 0.25 plus 0.25 equal to 0.5, which is equal to f1. Okay, at 3, when f3 plus equals to 1, and f3 if we do, then 3 into 0.25 plus 0.25 will be 0.75 plus 0.25, that is also equal to 1. So F1C is a valid CDF. Is it clear? Any doubt?
No, ma'am.
Okay. Then we have to find whether F2 is a valid CDF or not. So this is F2. Okay. Do you think this is a valid CDF? F2 is not a valid CDF. Why? See, here and here we have some problem. So everywhere else also we have some problem. F0 plus, when C is slightly greater than 0, the value is 0.5, which is not equal to F0. 1 point. Here also same. F of 1 plus is 0.75, which is not equal to F1, which is 0.5. Similarly here also, F3 plus equals to 1, which is not equal to 0.75, which is F3. We did not need to show 3. Any one violation would have sufficed. So F2 is not a valid CDF. What about F3? Do you think F3 is a valid CDF? No, here also same criteria is happening. No. Here it's not because of the right continuity. Here something else is wrong. Here f of minus infinity is not equal to 0. Whatever it is, however far we go till minus infinity, f of minus infinity will not be 0. It will be 0.5. So this is not a CDF. Okay. What about this one? This one, is it a CDF? F of minus infinity equal to 0, it holds. F of infinity equal to 1, this also holds. Right continuity, is it holding? Monotonically increasing, that also holds. Right continuity, yes, that also holds. Why? Because here F0 plus, the equal to sign is here. So if it is slightly greater than 0, this is 0.5, and F0 is also 0.5. Similarly at this point, F1 plus equal to 0.75, which is F1, and F3 plus equal to 1, which is equal to F3. So then F1 and F4 are valid CDFs. Is it clear? Okay. All right. So I'll just move on to the next one. So here we have omega equal to x, y, z, w. F is the events defined in okay. So here we have probability x equal to 2 by 7, probability y and z equals to 3 by 7. Their union also belongs here. Okay. So that will be 2 by 7 plus 3 by 7, that is 5 by 7. Then probability this is probability XYZ complement. So this will be 1 minus probability of XYZ is equal to 1 minus 5 by 7, that is 2 by 7. Normal things complicated with symbols. Okay. So then beta will be 2 by 7. So this one you understood why this is happening. Probability A union B, where probability A intersection B is 5. Sorry, probability A intersection B is 0 because A intersection B is 5. Disjoint X and YZ. So then their union will be this one plus this one. And then this is complement. This is present in the sigma field, so probability is defined. So it will be 1 minus this thing. 1 minus 5 by 7, 2 by 7. Is it clear? All right. And we'll move on to the next one. So here we have a function which is defined by these things, where B and C are real constants. So what will be the value of B and C? So here again, if you can understand, we are going to proceed with the right continuity thing, because that seems like one possible option to get the value of this thing. Okay. Fine. So here we'll start from the last one. So f of 6 plus is 1. This is a distribution function of some random variable. This means that f of x plus should be fx. It should be right continuous. So then f6 is how much? When x equal to 6, we'll put x, the value of x here, and we'll get it. It is 6 plus c by 8. If it has to be a distribution function, then 6 plus c by 8 equals to 1. This should occur, which implies c equal to 8 minus 6, that is 2. Is it okay? All right. Now once we have c equal to 2, we'll move to this thing. Okay, or these two. We'll see. All right. So C we have 2, we have gathered this. Okay, So now we have C equal to 2. Now we'll try to find out B. So for B, we'll use both. When F equals to 2. No, when F equals to 4. We'll proceed with this one and this one. Then we have F4 is 4 plus 2 by 8. That is 6 by 8. 3 by 4. Now since F is a distribution function, F4 minus should be less than or equal to F4. So F4 minus will be, we'll put value of x4 in this one. So it will be 4 square plus 4b by 32. That is 16 plus 4b by 32. Alright. We take 4 common, then 4 plus b by 8. Now we'll use this inequality and see what we get. So 4 plus b by 8 should be less than equal to 3 by 4. So that means 4 plus b less than equal to 6, which means b should be less than or equal to 2. Okay. So this is one equation, b is less than equal to 2. Same thing we are going to apply, we are going to compare these two right now. So f of 2 minus should also be less than or equal to f2, because this is a distribution function and it should be monotonically increasing, which means x1 less than x2 implies fx1 less than equal to fx2. This is the property that we are utilizing over here. Okay, so f2 minus will be 2 plus 4 by 16 less than equal to f2. f2 value is 4 plus 4b by 32. So this is 6 by 16 into 32 less than equal by 4 less than equal to 1 plus b. So then we have 1 plus b greater than equal to 3, which means b greater than equal to 2. So from these two equations we have two things. One is b greater than equal to 2 and one is b is less than equal to 2. Then what is the value of b? B is actually 2, because it has to satisfy both. So then the answer is C equal to 2 and B also equal to 2. Is it clear?
Yes, ma'am.
Okay. Thank you. All right. So now we'll solve this one. Sorry. So here we have x is a random variable with distribution function this. Derive the values of probability x belongs to 0, 1, 2. So if you find something like this, how will you proceed? So 0, 1 or 2. These are all disjoint things. So probability x belongs to 0, 1, 2 means probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. What is the probability x equal to 0? This is f0 minus f0 minus plus f1 minus f1 minus plus f2 minus f2 minus. So f0 is value of 0, we put it here 0. f0 minus less than 0 is also 0. Plus f1. f1 is how much? 1 by 3. Minus f1 minus is how much? 1 by 4. Okay. Plus this one is how much? f2. f2 is 1. And f2 minus is, we'll substitute the value of 2 here. 2 by 3. So answer is 1/3 minus 1/4 plus 1/3. 2/3 minus 1/4. 12, 4, 4 to the 8 minus 3. This is 5 by 12. This thing. Okay. Similarly, if I have to find out probability 1 less than equal to x less than 2, okay, so this one now, probability 1 less than equal to x less than 2. This means what? f2 minus f1 minus. So f2 minus will be, substituting the value of 2 here, 2 by 3 minus f1 minus will be 1 by 4. So this will be 12, 8 minus 3. This will also be 5 by 12. Okay. This one, 1 less than equal to x less than equal to 2. This will be f2 minus f1 minus. So f2 is 1 and 1 minus is 1 by 4, that is 3 by 4. And last but not the least, this one, probability 1 less than x less than 2. It will be f2 minus f1. So this will be 2 minuses, putting value here, 2 by 3 minus f1 is how much? Putting 1 here, 1 by 3, that is 1 by 3. Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So let x be a continuous random variable with PDF given by this thing. Okay. Now y equal to x square. So now we have to find the CDF of y. So CDF of y is probability capital Y less than equal to y. So this we can write as y greater than equal to 0. So this we can write as probability x square less than equal to y. Okay, when y greater than equal to 0, which is equal to probability x less than equal to root y. Okay. So then putting value of x as root y, what we'll have here, this will be minus infinity to root y half of e to the power minus mod y. dy. Okay. So now y equal to x square. Sorry, here we had dx when we were integrating with respect to y. So instead of dx, we are going to put it here. So dy will be 2x dx. So this thing we can, so this Jacobian will be del old by del new. So it will be dx by dy, which is 1 by 2x. It will be 1 by 2 root y. Okay. So that we have to substitute over here. 1 second. Minus infinity to root y half into dx by dy. Dx by dy will be 1 by 2 root y. Or 2 root y, what will it be? Alright. So then if we proceed, we'll have minus infinity to root y half e to the power minus root y I think this 2 should go away. Some 1/4 minus infinity to root y 1 by root y to the power problem I'm doing. Can anybody identify where the problem is? This thing will not be present somehow. Okay, was this question covered the last time?
No, ma'am.
Okay. Okay, so it seems like I'm a little bit stuck over here. Y equal to x square, this is fine. This step to this step, it's fine, right? You agree? Instead of x, we are substituting x with root y, and we had dx, so in that place we are substituting by dy by 2x. So x is 2 root y. That is what we are doing over here. And why is it not happening? Okay, if we just integrate it, what happens? So integration of x e to the power minus x. This is how much? X integration to the power minus x minus of d dx of e to the power minus x integration x dx. This x e to the power minus x minus e to the power minus x minus 2 x square by 2 dx. Sorry, am I following the correct integration thing? There was this rule I late. So this one will be option 2. Okay, I think I'm running out of time. I'll solve this one and bring this in the next class. If that is okay with you. Yeah, I'm going to do that. Okay, so the next class I'm going to begin with this problem and then move on to the other problems. So apart from this problem, anywhere else you faced any issues, doubts?
Ma'am, can you explain what is the meaning of this right continuous?
Okay, okay. Right continuous. So any function is said to be right continuous if limit, let's say at c some point, x tends to c plus fx equal to fc. So what it means is that, let's say we have a function like this. Okay, so at this point, if we move, let's say we are moving in this direction, x is moving in this direction, let's say this is some point k. So when we are moving in this direction, if there is a continuity over here, when we approach from the right side, if we come to very close to if we think of very small terms, okay, so as we are approaching more and more towards k, our fx will be closer and closer to fk. That will hold. But look at this point. Here we have a discontinuity. Okay, so here let's say the discontinuity point is only my c. So if we move x closer and closer to this c point, still we will not be able to reach c because there is some break over here. So that means that this is not right continuous. The concept is closer and closer and closer we move to c from the right hand side. In limiting sense, we should be available at fc, but this is not happening in some cases. So whenever this happens, then only we'll say that the function is right continuous. So for example, here we could be very, f1 is defined over here. f1 plus means we are from 1.5, 1.4, 1.3, we are moving gradually close to 1. So in a limiting sense, this one will become 1 by 3. So when I'm saying fx plus, I am saying 1 by 3 in a limiting sense. But at 1 also exactly, the function is defined as 1 by 3. That is why this is a distribution function. But here you see, where was that example? Valid CDFs, those. This one. So here if you see, this one was not this one was not a valid CDF, because if we move, if c is very close to 1, but it is not 1, very close, slightly greater than 1 also, fc is taking value 0.75. But at 1, the function is defined as 0.5. So however much we move c towards 1 from the right hand side, we will never be able to reach fc equal to 0.5, because slightest, even if you take, like, c is greater than 1, they are saying, if you take 0.000000000, something like this, then also we'll land up at 0.75. If you take even smaller, something epsilon even closer to 0, then also we'll land up 0.05. So from the right hand side, when we are approaching, let's say this is a real line, you're approaching from the right, however close you go to, if you are not able to reach the value of the function that is defined at that point of time, then it is not right continuous. Is it okay? A little bit clear?
Yes, ma'am.
Okay, thank you. Anything else? So this problem I'm going to solve the next day. Hopefully we'll get the answer then. Sorry, I got stuck. Anything else?
Ma'am, can you please send us the link of these questions, ma'am?
Link of the questions.
The solved questions.
Okay. So I think NPTEL team is going to share the link of this thing with you. I am not supposed to share. So what I do is that I submit these slides to NPTEL and then they distribute. So I think in the portal you'll be able to find, if it is not currently there, then you will find links to these slides and also the video links. Okay, just wait, or you can mail the NPTEL team for these questions.
Okay, ma'am.
Okay, thank you so much for joining. If not anything else, I'll close today's session, and the next session I'm going to start with the unsolved problems wherever I got stuck, and then continue forward. Okay, and one more thing, just tell me, week 2 assignments, when are they due?
Maybe 9th of August.
9th of August. Week 2 or week 1?
Week
Week
2
1
also.
is 9th of August, ma'am.
Okay.
Week 2, we have also very little time, ma'am, I think.
Okay. So hopefully whatever I have discussed today will help you solve week 2 problems. I am not allowed to exactly solve the questions that are given to you, but if you face conceptual doubts, you can ask me in the next class so that you are able to complete before the deadline. Okay, so thank you so much for joining. I hope to see you all in next class. Thank you.
Thank you, ma'am.
Thank you.